Hello everyone, welcome back to the Gate Engineering online learning classes. Today in this video we are going to discuss a problem on nodal analysis. So in this question we have to find the current through 12 ohm resistor I naught using nodal analysis, and we will also see a concept of the super node in this question. So let me begin with the discussion on this question. And just we recall that nodal analysis is applicable with the KCL. So we apply the KCL, Kirchhoff's current law. So we should know the current through each branch. So how can we get the current through each branch? If we know the potential at each node, we can easily find the current through the resistors by using the Ohm's law. So let me assume some potential at this node is VA, potential at this node is Vx, and potential at this node is VB. So it can be seen voltage VB is nothing but it is equal to 6 volt. VB is nothing but equal to 6 volt. What about this relation? Here in this branch, if we observe, here in this branch, if we observe, we cannot find any current through this voltage source because there is no resistor here. We should know the resistor to find the current using Ohm's law. So here, what we will do, we can find the voltage drop 2Vx, which is equal to Va minus Vx. So Va minus Vx is nothing but it's 2Vx. So by using this equation, we can know the relation between Va and Vx, and Va is nothing but equal to 3Vx. So now what we have to do, we will apply the nodal analysis at node Va. But how can we apply when we don't know the current through this resistor? But if I assume current through this branch is I, and current through this branch is I1, and current through this branch is I2. So it can be known I is equal to I1 plus I2. Yes, so current I is equal to I1 plus I2. So we can write current I, which is nothing but I1 divided by, which is nothing but I1 plus I2, and I1 can be written as Vx divided by 6, and I2 can be written as Vx minus Vb divided by 12k. So be careful. This question is intentionally framed with the 12 kilo ohm, where all other resistors are in the ohm, because many of the students make mistakes in the units also. So you have to be careful by considering the 12 kilo ohm, because this will become 12,000 instead of 12. So be careful when solving such kind of the problem. So now here we know the current in this branch is I, which is equal to Vx divided by 6 plus Vx minus Vb, which is nothing but 6 volt divided by 12,000. So how can we solve now? Now I will apply the nodal at this point Va. So nodal equation will be Va divided by, nodal equation will be Va divided by 12. This is the one current through the 12 ohm resistor. Current through the 6 ohm resistor will be Va minus this is 6 volt divided by 6 plus I is equal to 0. So now this I will be replaced by this equation. This I will be replaced by this equation. So how can we write it? Va divided by 12 plus Va minus 6 divided by 6 plus Vx divided by 6 plus Vx minus 6 divided by 12,000, which is equal to 0. So now if we solve this, and we have already observed that Va is nothing but 3Vx. We have already observed here Va is nothing but 3Vx. Va is nothing but 3Vx. So if we substitute this equation in this equation, we will get equation as 3Vx divided by 12 plus 3Vx minus 6 divided by 6 plus Vx divided by 6 plus Vx minus 6 divided by 12,000 is equal to 0. So it is very straightforward. We have a single equation with a single variable. So by solving this equation, we will get a value of Vx, which is 1.09 volt. We got the equation We got the value of Vx, which is 1.09 volt, and we have already observed that Vx, already observed that Va is equal to 3 Vx. So Va can be calculated as 3 multiplied by 1.09, and it will be equal to 3.27 volt. Now, what is our aim? We know the potential at each node. This potential is 3.27 volt, this potential is 1.09 volt, and this potential is 6 volt. Now, our aim is to find the current through 12 ohm resistor. So, this current will be voltage Va divided by 12. So, this current will be voltage Va divided by 12. So current I naught that we have to find through 12 ohm resistor is Va divided by 12, and Va is nothing but 3.27 volt divided by 12. So this I naught is nothing but it is equal to 0.2725 ampere. So it's very good problem, and in this question we have seen how to solve the problem when any voltage source is given between two node, and where we cannot directly apply the nodal analysis, so we converted this in the super node and we apply Va voltage here, and this current is dividing in these two branches. So by using this concept, we can easily solve the problem, and we are getting the current I naught, which is 0.2725 ampere. I hope you like this video. Thank you very much for watching this video.